All right, so welcome to 8.8, third day of Pythagorean theorem. Today we're going to use it to find distances. All right, so let's think about distances for a little bit. So find the distance between points A and B. So we literally have to count boxes 1, 2, 3. The distance between points A and B is 3 units, we'll say. All right, and points B and C is 1, 2, 3, 4 units. Now, what we're going to do today is more like find the distance between points A and C. Now, you cannot count boxes when right? So this first one was a horizontal distance. It was across, horizontal. And the second one was a vertical distance. But let me draw that whole thing in now. And hopefully we're seeing a right triangle. And it turns out you can count the distance of this leg, count the distance of that leg, and then you can use Pythagorean theorem to find the diagonal distance there, right? So we know that two legs are 3 and 4. You already know the answer. And so 9 plus 16 equals 8 squared, 25 equals 8 squared, and right, distances have to be positive, and so the distance here is 5 units. Notice you can't count it. It's made up of a bunch of little fractions of these boxes, of cuts of these boxes, but the distance there is 5 units long. That's really what we're doing today. Right, so we had one where we had to find the distance, right, that you could drive. If you had to drive around a lake, there were the two legs, and there was the hypotenuse. If you had a vehicle, it could somehow drive right across the lake. We're going to do that as well. All right, so we're going to have to draw a right triangle. So we have to know what a right triangle looks like after all these days to find diagonal distances. So find the distance from A to C. That's all the way here. All right, so now, just like this is exactly like when we were doing slope. You had to draw your slope triangles. So start at the upper one, go straight down, and then when you get even with the other point, you go straight across. So we're going to find the distance from A to C. Now you can just count for the legs, 3, 4, 5. That is 5 units long, right? We just count the boxes, 1, 2, 3, 4, 5, 6, 7, 8 units long. And so our legs are 5 and 8, and we're going to find this diagonal distance. 25 plus 64 equals 8 squared. 64 plus 25 is 89. 89 equals h squared. I don't think I counted this right. It's 6, right? I didn't. See, this is why, because I knew I wasn't going to start off with one that came out irrational. So 36 plus 64, yeah, because it's 1, 2, 3, 4, 5, 6 long. So this is 100. And so I'm losing my mind here. And so yes, 10 is the distance. So the distance, the length of AC is 10 units. Let's forget that. Totally wrong. All right, distance to A to E. So now I'm going to do A to E. All right, so we come down here and we go straight across till we get there, making a bit of a mess. Now, so say I don't want to make that mess. Say I want to go the other way. All right, I can make the triangle this way. I can go this way, out to there, over there, and there is our right triangle. Same exact right triangle, right? 1, 2, 3, 4, 5 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 there. And we're finding that diagonal distance. So 5 squared plus 12 squared equals hypotenuse squared. We've done this one before. And that is 169 equals 8 squared. So the hypotenuse must be 13. And so we say AE, the distance from A to E, or line segment AE, is 13 units long. Okay. All right, so that is not a right triangle, right? There's no right angles here. So what does it say here? Find the length of KM. So find the length of that one. And round the irrational square root to the nearest whole number. All right, so we need to draw a right triangle where that's the hypotenuse. The triangle that's there is not right. This is a confusing problem. You go straight down and straight over. All right, there's a right triangle. Or you could draw it above, but we need a right triangle. And so this leg is 1, 2, 3, 4 units. This leg is 1, 2, 3, 4, 5, 6, 7, 8 units. So it's 4 squared plus 8 squared equals hypotenuse squared. 16 plus 64 equals h squared. 64 plus 16. 80. 80 equals h squared. All right, it says round to the nearest whole number, right? Well, the square root of 80 is the answer. And well, we know the square of 81 is 9. So this is approximately 9 units long for what? Km. Right? Right? Square root of 81 is 9. This is a little less than that. Okay. Okay, so we talked about this. So how do you do this without the picture? So the vertical distance here, right? Right? So it was easy enough. I was counting boxes, right? But we know how to find a vertical distance because we would do it for slope, right? y2 minus y1. The vertical distance there is 9 minus 1, 8 units, right? We did that for slope. So now guess what? We're going to find the horizontal distance, which we used to call the run. Still do, right? So what do you do for a horizontal distance? You subtract x2 minus x1, right? Same thing. So 8 minus 2, and that is 6 units. Now, remember that these have to be positive numbers, okay? They have to be positive numbers, okay? Because distances are always positive. That's why you don't do 2 minus 8 or 1 minus 9, because you know the answer is positive. All right, so the diagonal distance then is 6 squared plus 8 squared equals h squared. I'm not going to do this out. Hopefully you know that this has to be 10. We've done that many times. Okay, so now let's see this. Okay, so instead of doing it that way, we're going to subtract the y coordinates for the vertical distance and then square it. We're going to subtract the x coordinates for the horizontal distance and square it, and that's going to equal the diagonal distance squared. So let's do this. So we're going to draw this, right? Instead of drawing it like that, you're just going to do that. So subtract the y's, 9 minus 0 squared is 9. Now notice this. If you do 0 minus 9, you're going to get negative 9, but negative 9 squared still 81. So it doesn't matter which order you do it now. Okay. X squared. So I started with the 9. I should be consistent still, although it actually doesn't matter. 7 minus negative 5 is 12, and 12 squared is 144. Okay. Now, right, are you tired of crossing out the negatives? All right, so what you can do, instead of writing it this way, we can just take the positive square root, like this. And instead of writing d squared, write d or h. We're going to write d instead of h there. All right, so what did I do there? I don't want to go over that again. Instead of writing d squared every time, we can take the square root of both sides and just write it this way. All right, I find it sort of awkward writing this huge square root symbol, but this has a huge advantage. And that advantage is that when you get to the end, you don't have to cross out the negative solution, right? There's only a positive solution there, right? Because we didn't write positive and negative. We just wrote positive because we know a distance has got to be positive. And notice I used d for distance instead of h. Why did I do that? It's tradition. So this was 15 units long. So I should put units. All right, so let's see this. So the square root of the y coordinates squared, and it doesn't matter the order because you're going to square it. Square of the x coordinates subtracted will equal our distance. Okay, so let's do that. So we subtract the y's, 9 minus negative 6, right? 9 minus negative 6, that whole thing squared would be 15 squared, which would be 225. Okay. Subtract the x coordinates. I started with the 9, so let's be consistent. 7 minus negative 1 squared is 8 squared is 60. So 8 squared, which is 64. All right, and then I'm just going to make that all equal to this distance. And so 64 plus 225 is 289. Square root of 289. Well, remember, the square root of 225 is 15, so it's some number a little bit more than 15. And I think this is 17. Let's just double check it. 7 times 7 is 49, and 11, and then we multiply by 1. Yep, 17 times 17 is 289. So this is 17 units, right? So you subtract the y's for the rise or the vertical distance, right? You subtract, and that was what, 15. You subtract the x's for the horizontal distance, or what we call the run when we're doing slope, which was 8, and then this was exactly 17. It came out nicely. So I just did that, and there it is, right? This is what I've been doing, all right? x1 minus x2 squared plus, right, it doesn't matter which is first. I've been writing the y's first, haven't I? Right? Now, you solve the equation for h. What do you do to both sides? You take the square root. And so, all right, and that's what I've been writing. This is called, has a name, and it's called the distance formula, as long as I now replace this h for hypotenuse with d for distance. There it is. I put the d on the other side. All right, so you have no pictures whatsoever. So we're going to subtract our x's. 4 minus 1 is 3. Since we're going to do 4 minus 1 is 3, I'll write it out. Don't be lazy. All right, I can get on your guys' case for being lazy, and I shouldn't be lazy. 4 minus 1, and we have 2 minus 6. And again, this is good. I'm going to show that it doesn't matter that I went that way, because 4 minus 1 is 3, 3 squared. This is negative 4 squared, but it's not going to matter because you're going to get 9, you still get 16. And so this is the square root of 25, and d equals positive 5. So this is what they traditionally use in high school for this. But notice, yeah, my way you have to cross out the negative answer that you get at the end. This way you don't, but you have to write this square root symbol for each step that you write down. I think my way is better, but it's called tradition. And so we're going to make sure that you're ready for other teachers besides me. All right, and so this is the 3, 4, 5 right triangle we've done many times. Okay, so let's do that. All right, so we're doing d equals the square root of 4 minus negative 8 squared. D equals 4 minus negative is 12. 12 squared is 144. I'll do a little less writing here. And then subtract the y's. 10 minus 1 squared is 9. 9 squared is 81. All right. 144 plus 81 is 225. Square root of 225, 15. And there it is, right? If you have a picture, you get to do all that. Right? We had a side of 10 minus 1, 9. We had a side of 4 minus negative 8, 12. And we had a hypotenuse of 15. So let's practice. All right, Jason lives across the lake from work. He drives 12 miles west. All right, so west. So this is home, and this is work. And it says he drives 12 miles west. That's this way. And then he drives 9 miles north. Right, north is that way. And if he could drive straight there, how far would he have to drive? Right? We've done this. Now, why is this different than the ones we did before? Well, the ones they did before, I drew the right triangle for. Now you have to imagine the right triangle, but it really is the same thing. So normally he's driving 21 miles every day. But how far would he drive if he had to go right across? 9 squared plus 12 squared. I'm going to go back to the normal way. I do it. 81 plus 144 equals h squared. 225 equals h squared. And so it is 15 miles. All right? He gets to save 21 minus 15. He gets to save 6 miles if he can drive across the lake. Okay, so I'm going to use the traditional distance formula for this since there's no picture. So I'm going to subtract my x's first. -4 minus -1. And I square that whole thing. And I need parentheses around the parentheses there. And then I'm going to do -5 minus 2. That's -5 minus 2, yeah, squared. And -4 minus -1 is 3, right? -3, so this is -3 squared. -5 minus 2 is -7 squared. And this is here is intentional. So you see that even if you get +3, -3, doesn't matter. That's 9. That's 49. And 9 plus 49 is 58. And that's the answer, the square root of 58, because the square root of 58 is simplified. It doesn't say round it, right? You know, it is approximately between what, 8, 7, and 8, right? It's what, 6 and 9, so it's a little closer to 8, so 7.6, 7.7, but I didn't ask for, oh, it says, in fact, I asked for the exact distance, so don't round it, square root of 58. The square root of 58 is simplified. 4 doesn't go in there, and neither does 9 or 16 or 32, no. Find the distance between B and D. So that's this distance, right? And this is a square, right? So what does that mean? It means this one's 10. It means they're all 10. So they're, right, the two legs are both 10. And so we have 100 plus 100 equals h squared. 200 equals h squared. It says find the exact distance. So the exact distance here is the positive square root of 200, right? But square root of 200 can be simplified because it's the square root of 100 times the square root of 2. So the exact distance written correctly is 10 times the square root of 2, right? Because you have a perfect square factor in 200. All right, good luck with your homework.